Hello, everyone, and welcome to our SETI Live. I'm Sara Jennings with the Frontier Development Lab. The Frontier Development Lab is an applied artificial intelligence research accelerator, and we bring in PhDs and postdocs from around the world and put them together, pairing them with machine learning researchers and space scientists to work on exciting challenges in space science and exploration. So today I am here with our FDL partners, and we're going to be talking about the future of space exploration. But before we dive into our awesome panelists for the day, I'd like to turn it to the CEO of the SETI Institute, Bill Diamond.
Hi, Sarah. Thank you. And hello, everybody. Thanks for joining us today. And thank you as well for our partners who are not only instrumental in the execution of the FDL program, but wonderful to spare their extra time with us and with all of you today. And it's nice to see you all out there. Many of you I know are regular followers of our SETI Live events, and we love to see you back here. And some of you hopefully are new, and we welcome you and hope you'll keep coming back for more. So by way of quick background, for those of you who might be new to the SETI Live program, the SETI Institute is a nonprofit research and education institution, and our mission is basically to understand the origins, nature, and prevalence of life and intelligence in the universe. And we've been running the FDL program in partnership with NASA, and private industry, and other government agencies and foreign government entities for now 6 years. So this is our 6th year. Very exciting, amazing work that is all about the application of advanced machine learning and artificial intelligence tools and techniques to deep science questions that relate to heliophysics, earth science, astronaut health and space medicine, exoplanets, astrophysics, a wide range of topics, and really demonstrating the efficacy and power and capability of interdisciplinary teams, scientists working together with diverse backgrounds from compute to deep science knowledge, and the efficacy of intense research sprints that have been carefully architected and executed, but leveraging massive data sets to address these deep challenges. So that's a little history of the FDL program. And as Sarah and all the rest of our panelists know, tomorrow is the final event for this year's FDL program. And the event is taking place at 12 noon Pacific time, which is 3 p.m. Eastern time. And it's going to have all the teams from the FDL program this year talking to the audience about this program and talking about their research, what they achieved, what impact it had, how they did their work, et cetera. So it's a very exciting, lively show with lots of amazing science to be talked about. And our partners will be there as well. So please, if you're interested in this, and if this today's SETI Live event piques your interest, by all means, check out fdl.ai to learn more about that program and register if you'd like to attend. And with that, I'm going to turn it back to Sarah so you can introduce our partner guests.
Great. Thank you, Bill. And I'm really excited today. We have our FDL partners. So as Bill mentioned, this is our last week of FDL. So today I have with me Alex from the Institute for Simulation Intelligence. I have Lauren from the Blue Marble Space Institute of Science. I have Bob from the Luxembourg Space Agency, and Sashi from Intel. So I'm very excited to have this really amazing and diverse group of panelists with us today talking about the future of space. So to kick us off, I'd really like to hear from you, Bob, about what Luxembourg is planning for this future of space exploration.
Thank you, Sarah, for the question. So in Luxembourg, as maybe some of you know, we launched the Space Resource Total initiative back in 2016, under which we conducted many different activities. For example, we published a law on the utilization of space resource similar to the one in the US. And basically, we are very interested to see how space resources will, or the utilization of space resources will enable us to have a more sustainable space exploration and set up an in-space economy. Obviously, as a small space agency, we do not have our own missions. we contribute to missions from our partners. We work closely with our industry, and we also recently established the European Space Resource Innovation Center in Luxembourg. In this center, we partner with the European Space Agency, and we look into we conduct research projects around the production of oxygen and metal on the lunar surface. And yeah, so that's very exciting topic to see how space resources will change exploration in the long term.
And I think it's important to note that that Luxembourg Space Resources and now the Luxembourg Space Agency have been partners in the FDL program now for 4 years, and with a special focus on space resources. And it's been a wonderful and amazing partnership that, among other things, included a visit from the Crown Prince and Princess of Luxembourg to the SETI Institute back in 2018, which is something none of us will ever forget. It was really wonderful. And it's great to have you here, Bob, and have Luxembourg as a partner.
Thank you.
Great. Thank you so much, Bob. And yes, really excited to see at the showcase the FDL lunar work from this year. And my next question is more on the machine learning side. And so I'm going to ask Alex and Sashi. I know that this is kind of a big question, but how do you think machine learning will impact the future of space exploration and what becomes possible? Alex, you want to go first?
Sure, that is definitely a big question. Maybe I'll take part of it, and Shashi can build on it afterwards. Machine learning is coming to a space now where we can really complement what humans can do as far as understanding the world and ecosystems around us, and that includes the space systems, but then also build better technologies to explore, whether that's robotics or in simulation, building better models of the systems that we will eventually build or ship to the moon, Mars, and so on. Shashi, do you have more to build on that?
Yeah, I was, reflecting on what you were saying, and then, what I've seen in FDL is that before anything even launches, there's a whole set of processes and thousands of decisions that need to be made. And from a practical perspective, ML will augment those planners and accelerate those processes. So instead of it taking years to plan a mission, maybe it'll take months, as we're starting to see, and maybe it'll come down even further than that. I mean, that's kind of like back office stuff. How do you augment people to make them, more capable? But that same question then becomes true for the people who are going into space. So for the crewed missions, I'm excited and hopeful that machine learning will become an augment for them too, to make a sense of all of the data that is going to be coming at them, not just related to their mission, but how to survive in space, and to make I hate to say it this way, but make going to space a little bit mundane. You may need, when we get to that point and we've used machine learning tools to get there, then I know we've kind of made it. So,
well, Shashi, I don't think it'll ever be mundane, let's hope, but at least we can make it something that, from a safety perspective and health perspective, is a little straightforward and less worrisome. And that's why the astronaut health and space medicine projects in particular have been so interesting, because they also inform medicine and medical techniques and medical diagnostic techniques on Earth, because what's important if you're going on long duration missions is very, very early diagnosis or indications of any problems that might be coming along in your future. And so if we can advance the state of the art in that diagnostic technology through the application of AI and ML tools, not only do we make long-term space missions safer and more viable, but help medical research and medicine here on Earth. So it's fantastic.
That's actually a great segue, Bill, into my next question, which is related to health. And really excited to have Lauren and Sashi, who have both been an active part of the Astronaut Health Challenge this year. So in regards to health, astronauts, they're definitely truly explorers. They're dealing with a lot of intense environments, and we're still learning about how things like radiation and affect them. So where do you see machine learning fitting into this narrative? So I'd really like to hear from Sashi and Lauren. And Lauren, if you want to go ahead and kick us off.
Yes, definitely. Thank you, Sarah. So, one of the biggest challenges here is there's a lot of difficulty in getting space biological data just to study the physiological effects of spaceflight stressors, which include radiation. And so this ends up resulting a lot of the time in smaller data sets than we'd like, especially for machine learning applications. And so I really feel that machine learning is going to be powerful for, in the future, maybe automating experimentation so that we can have larger data sets and perhaps even aiding in experimental design. And then also on the other end, machine learning analysis of the smaller space biological data sets that we've already amassed is going to help us and is already helping us find insights for human health in space that we aren't able to find with traditional statistical methods. Sashi, maybe you have something to add here.
Yeah, what I've loved about watching the astronaut health team unfold is, I started with the idea that astronaut health would be like we're going to be making the holodoctor from Star Trek. I got really excited about the thought of the automation and the automatic understanding and the augmentation of those who are basically monitoring the health of astronauts. From a practical perspective, what we'll see, without spoiling too much of it, is the data is so sparse right now, and it's such small data sets, and they're siloed all over. And I think the team this year in FDL did an amazing job of applying federated learning to break down those silos. And I kind of liken it to like if you've ever heard the story of stone soup, everyone contributes a little bit to make an amazing soup here. And but you can think of the data as those contributions. And if we can break down those barriers to make those the contributions of data to train these algorithms, then maybe we can build a system that would allow us to facilitate the creation of many algorithms. So we'll have an ensemble of tools that will augment, space doctors, space medics, if you will. In terms of machine learning fitting into this, it's a tool, and bringing this tool and making it practical to apply for the health of astronauts is an amazing goal. And I would also look forward to what are the implications as we bring that back down to Earth.
Shashi, you talk about the algorithms and the data. I think it's so important for people to understand the role that the data plays. And you mentioned both sparse data. Lauren mentioned this as well, and also the fact that data sets that are relevant to a problem can be dispersed and siloed. And how do you get access to them? How do you aggregate them? How do you get them ready, so-called, as we call it in the FDL program, AI ready? So there's a lot of work that involves just the data access and preparation before you even get to apply the algorithms. And so it's like a doubly complex problem. And then you have to overlay the science. So it's really something.
Yeah, definitely. Thanks, Bill. And thank you, Sashi and Lauren. I want to do a quick shout out to our audience members. It looks like we've got quite an international group watching us today. So we have Oklahoma, Dubai, Denmark, India, Australia, Oregon, Netherlands. Thank you all for joining us. So the next question that I have is kind of bringing things a little bit more maybe down to earth is if Alex, if you can talk a little bit about what simulations and digital twins are and how they can help us understand mechanisms off planet as well as on Earth.
Yeah, for sure. I like this question because the digital twin or definition is becoming a bit conflated these days. A digital twin is essentially any a representation in silico, so in software, of any real world system or process. And that can be anything from a digital twin of jet turbines or Tesla, apparently a digital twin for each car on the road. Or it can be a digital twin of the coastal region ecosystem like we've been building with FDL this year, or a digital twin of lower Earth atmosphere for spacecraft collisions and whatnot. And a digital twin can be useful in many ways when it is actually more than connecting data and sensors in the real world. When it is really trying to build a robust, high fidelity, reliable model of these real processes, then we can start asking what if questions. We can do counterfactual reasoning that can inform decision processes, policy decisions. And it can also allow us to do experiments in silico before we take it in situ. And this is something that we're starting to do with some of the projects or motivated projects at FDL, and it's also our focus here at ISI is really looking at all the things that we can do with AI-driven simulation in silico, so then we can optimize the domain scientists in the lab to really speed up their workflows and invent really new workflows. So this is human-machine teaming with these simulation systems, kind of like Shashi had alluded to earlier with space exploration and machine learning in general. So we see this as really a key way of actually explaining when people say, if we solve AI, we can solve everything else. It's really, we're developing AI to team up with the human experts to solve the real challenges.
Yeah, that's a really great point. I think a lot of people, when they think of AI, they think that, you're just completely eliminating the human. And a lot of what we do is actually we're building these tools. So that's a great point. So my next question is for Bob and Lauren. I was wondering if you had some current challenges that need to be overcome to progress space exploration, which I also recognize is a pretty big question as well. But Bob, do you want to go ahead and start?
Sure. Yes, so it's a pretty big question. I think in Luxembourg we clearly see space resources on the long term as a big game changer, and so I think we need to learn how to use the space resources and how to use them in a meaningful way. I think once we'll be able to produce oxygen on the moon, or hydrogen or water, I think we start to see a whole new generation of space architecture, and this will have a big impact. So to get there, obviously we need to learn a lot, to develop a lot. And first, we need to understand what resources are where. I think on the moon, that will be the next destination. Is very interesting, very concrete with the Artemis program, and so on. And I think this is certainly the next step, is to learn more about what can we expect on the moon. Where do we want to go there? How do we get there? And these are all areas we developed the challenges with FDL over the last years. And I think that's very exciting also to see the results of this year's challenge, and to see how this contributes to future missions.
Thanks, Bob. Yeah, it's been great that we've been able to tackle so many challenges, but it sounds like there's still definitely work to be done. So now I'd love to get Lauren's.
Good news for the program, Sarah.
Yeah, it's good news for us. We've still got things to work on. So
every question we answer, we just derive also 10 new questions. So there's permanent job security here.
Yeah. So I'd love to get Lauren's perspective as well on this.
Yeah, so absolutely, this is a very large question. There are lots of answers here, but of course, as part of the astronaut health team this year at FDL, I really have been spending a lot of time thinking about the physiological effects of spaceflight on, mammals, particularly humans. And in particular, we're beginning to learn a lot about the effects of radiation, microgravity, changes in CO2 levels, so on and so forth, on the ISS, but we are still needing to sort of push the boundaries and understand for long duration space flight or deep space exploration, what do those physiological effects look like? And then once we've characterized them, what can we do about them? What are countermeasures? So I think there's a lot of work to be done there, definitely.
Thanks, Lauren. Yeah, that's really good to hear from the astronaut health perspective as well, what other things we can tackle. So my next question is for all of you. I know that everyone here loves space, and we have a lot of exciting new upcoming missions. And I was just curious which one you were most excited about. And Bob, do you want to go ahead and start?
Sure. So I personally, I have no particular mission which I'm most excited about. I think that when it comes to the moon, there are so many. I think that's a plan for the next 10 for the next decade, and that's very. I think we are at the beginning of a very exciting period here, and it will be very interesting to follow all the different players. And I think what's different this time is that we have many different countries involved in space exploration. We have big players from the private side that are involved that will play a very important role in the future. And then I think personally, I'm very interested to see if we learn how to use these resources and produce them and have maybe long duration missions on the moon and so on.
That's a great answer. I personally really love the moon and all of the lunar missions as well. So we've got a lot of exciting things coming up. Sashi, do you want to go next?
Yeah, absolutely. I would be absolutely remiss if I didn't say I've been on the edge of my seat watching updates on Starship and where that's going. And if you haven't seen, up on YouTube, there are, behind the scenes tour of Starbase and all the planning that's going into that launch. I feel like that's history in the making here. But beside that one, some near and far term missions I'm really excited about. Lunar is near and dear to my heart as well. We started with supporting FDL in the lunar challenges, and the idea of in situ space resource utilization is a powerful one. So the first automated rover launches, I think, are slated to happen next year. And in fact, I think iSpace is one of the first that's looking to land a rover on the moon. And these are not like the big rovers that you would see, that are going to Mars. These are small rovers, inexpensive ones that are meant to have some autonomy. So the idea of rovers with autonomy and going to the moon is a compelling one to me, and particularly as the possibility of them cooperatively working together. And then thematically, that requires a lot of compute, and thinking about the greater use of compute in space. There's missions, in planning towards Europa and to the outer planets that are going to incorporate this high-performance space computer, which is, I think, in the planning stages right now and is public. So all this we can talk about it, but that's kind of captured my imagination as to what kind of science can be done if you put a heavy amount of compute on a platform that's going out to like Jovian moons. Anyway, I've said a lot here, but I'm geeked out about a lot more than this, so I'll just pause right here.
Thanks, Sashi. Those are really great things. And yeah, Alex, you want to go next?
Yeah, sure. I'll mention something that might be a little bit off the beaten path or out of scope here a little bit. If people are familiar with manufacturing in space, and in particular, there's namely one startup, Varda Space Industries, part of this new space economy that's really taking that on. And I see this as a really important step in a few ways, and kind of like a step function, if you will, because I remember years ago, I had an internship at NASA Ames, and I was developing systems engineering for a project for kind of like the FedEx for the ISS. And this was just conceptual for one day for manufacturing capabilities in space and returning scientific payloads and so on. And it was ahead of its time. And now is the right sort of time. And it's also the right sort of time to kind of ride the momentum or carry the momentum of this new space industry, the private sector. And then looking ahead 10, 20 years, whenever we think about a lot of these sci-fi books and movies, more often than not, they have some sort of space robot farms, manufacturing facilities, whatever, these massive structures that somehow get built. And this seems like we're kind of trending the right direction. So that's what excites me.
Thanks, Alex. Yeah, I think we're definitely getting there. Awesome. And Lauren.
Yeah, so I think I have to echo you, Sarah, and Bob talking about the lunar missions. That's really something I've been excited about because, I wasn't around during the first lunar missions, and but I grew up hearing about them from my parents, and I'm just so excited to be here and watch history unfold in the next couple of decades.
Thanks, Lauren. Great. Yes. So now we're going to go ahead and take a question from the audience before I ask my closing question with this group. So the question from our audience is, to what extent, in collaboration with NASA, has SETI established principles to AI development within which work can be carried out? And Bill, I'll turn this to you first.
Sure. Well, first, I'm going to go back to your last question because you didn't give me a chance to answer.
Oh, I'm so sorry. Bill, what is your favorite mission?
So I'm going to go a little bit further out than my colleagues here, and then a lot further out in terms of missions. I'm obviously very excited about the Perseverance mission, which is not a mission that's over. It's a mission that's ongoing. And this is the rover on Mars and the Ingenuity helicopter as well, which is capturing amazing new images and new learnings from the red planet. And the Perseverance rover is designed to look for signs of life, extant or extinct, on Mars. And so that, from our point of view, studying life in the universe is, of course, extremely exciting. The SETI Institute, in partnership with NASA Ames, has an instrument on the Curiosity rover, which is called an X-ray diffraction system, the so-called ChemMin system for chemicals and minerals analysis. And it basically studies the composition of the surface material of Mars. So, but Perseverance takes us deeper and will leave samples behind for future return to Earth. So it will cache samples. It's also got onboard technologies that are capable of detecting the building blocks of biological systems and life itself. So that's really exciting. The other one I'm really excited about, which we all hope will launch later this year, is the James Webb Space Telescope. To the extent that, Hubble transformed our understanding of the cosmos and our place in it and gave us these most unbelievably stunning images and opened our eyes literally to the heavens. I think that the James Webb Telescope is going to do that with exponentially more knowledge and excitement that is gained. And among other things, James Webb is going to be able to use infrared spectrometers to probe the atmospheres of nearby exoplanets and potentially look for biosignatures in those environments. So again, this is a sort of an astrobiology, life in the universe type of capability. So it's right up our right in our wheelhouse at the Institute here. So I'm very excited about those two missions. And of course, the lunar missions are exciting, and the lunar project we did this year at FDL, which hopefully you'll hear more about tomorrow, is really amazing. But the question that's been raised is really an excellent one. And how are we, what are we doing at the Institute and in partnership with NASA in terms of principles, establishing principles for AI development? So we've been doing a lot is the answer to that question. It's a question we think about a lot in terms of what did the application of AI and ML tools mean to science? How do we do them ethically and properly? How can we trust the results? What do we do to share the work with the public? So first and foremost, one important characteristic of the FDL program like all NASA programs and SETI Institute programs, the work belongs to the public. So everything we do is open source. The data sets that we utilize are open source. The data sets that we produce through the application of algorithms and through the research programs are open source. We make all the results available to everybody. But lots of people, including people at NASA, including many people in the scientific community, have questions about, if we don't understand what is happening in the AI machine learning algorithm, to the extent that it's a black box, can we trust it? Can we understand what's happening? And so to that extent, the FDL program, in partnership with all our industry and NASA partners, have been developing what we call TRL, or technology readiness level, which is something that NASA uses to describe or understand and characterize hardware, space hardware, instruments, equipment, et cetera, understand the extent to which those technologies are ready for launch and ready to be deployed in space applications. So similarly, we're trying to apply the same discipline to our machine learning tools and techniques, is to understand and advance them in the sense of technology readiness level, which I think also translates to sort of trust and reproducibility. So if we can demonstrate reproducibility of the algorithms, if we can demonstrate an understanding for what the algorithm is doing and how it's working, then we can establish that higher TRL level. So and then I guess lastly, and then I'd like to hear from our panelists on this as well. We're very interested in making sure that other concerns that come along when people talk about applied AI and ML, such as bias in the outcomes or bias in the data sets. How do we make sure there's no bias, either intentional or unintentional, in the data that's being utilized to investigate or inquire about a particular challenge or problem? And of course, in the case of our medical research programs, we want to make sure data is anonymous and doesn't contain any information that goes beyond the intent of the work being done. So there are lots of issues around the ethical use of AI, the insurance of issues around data integrity and the absence of bias, around open access, both to the data pre and post program, and also the level of trust that we can apply to the algorithms to address that issue of what's happening in this black box. So love to hear the perspectives from everybody else on the panel.
Yeah, and Alex, I mean, you've really been the thought leader behind the TRL for ML. So I really love to hear any thoughts or builds that you have on what Bill just mentioned.
Yeah, sure. I think Bill really covered a lot of the bases there quite elegantly. One thing I'll mention, maybe double clicking on a point that Bill made about machine learning ethics and bias and being really diligent about this. What we see in the broader ML community is an awareness of these problems, but it seems to be very after the fact and kind of even years after the fact, where there'll be published papers and then someone will implement that model, deploy it, find some bias, something hazardous, and then we'll circle back and have to just iterate that way. Whereas when we look at the traditional TRL framework in aerospace and spacecraft, it is very much preventative and much more rigorous. So what we do with our machine learning technology readiness levels, which we're publishing and preparing materials open source for people to use and implement, the process is we're trying to bring some of that preventative, really rigorous reviews and testing and verification validation to the machine learning process, and in particular this area of bias and ethics and so on. So that's something that I think we, SETI, FDL, and so on, can be in a unique position to actually bring this to the machine learning community.
Thanks, Alex. That's really good builds. And we are nearing the end of our time together, and I know it's a really busy week for everyone. So I just have one last question. As Bill had mentioned previously, we do have our showcase tomorrow, and we're sharing that link on social media. It's live stream, so anybody can join. And I would love to know from all of you what you're most looking forward to for that showcase. And Bill, since you were keeping me on track, Bill, do you want to kick us off here?
Well, I'm looking forward to hearing each team's not only the work they did and how they did it, but the impact of that work and what difference it makes in terms of a contribution to the specific field, but potentially even in broader areas. So I'm really excited to hear what the teams are going to say about here's what we did and here's what we achieved and understood and here's why it matters. I think that's going to be really, really interesting and lots of fun.
Yeah, definitely. Me too. And Bob, you want to go next?
Yes. So obviously, I'm also very much excited to see the result of the challenge we sponsored this we supported this year, and see the high resolution images. And I'm as Bill, I'm also very interested to see how these higher resolution images will contribute to a better planning for future space missions, and how they will be used. I think over the next years from different players will be very interesting to see.
Thank you, Bob. Yeah, definitely. If you're interested in that, tune in tomorrow. And we'll go next to Lauren.
Oh, yes, definitely. I'm really excited for the showcase tomorrow. And I'm really most interested to hear about, as Bob said, the impact of all of these different challenges on future space missions. So, how can some of these novel algorithms be used in the future? And, I've been really involved in the astronaut health team, and I've heard a lot from the different teams, but I'm really excited to see it all wrapped up and nicely done at the end.
Yeah, that would be great to be able to see everybody all at once. And I'll go next to Sashi.
Yeah, I think the inspiration that you'll see, in these presentations it's hard to capture in words. So going and seeing it, I would say, is really important. Of course, the implications and the ripple effects that the research may have in other areas and other disciplines, I think that's my favorite part as well. But there's a little part that kind of like an insider's view that you can see the change in the way that the researchers themselves talk about it. From the very beginning of the program to the end, they start, it opens their thinking in a sense. And then when they go off and do projects afterwards, it's kind of breathtaking to see just how they use their experience with FDL. In terms of specific projects, I'd say, again, Lunar is near and dear to my heart. I love seeing the progress that's made in there. And you can see over year in FDL, they're building things that generally work together. And we're seeing that in astronaut health too. So Intel is one of the partners for astronaut health. And I think the problem that they're solving, there's 3 big problems that they're solving, and I'm not going to spoil it for them, but you've got to see just how difficult what they're doing really is, and to appreciate it, and what it could open up for not just the research, but to the operations, and how it could be deployed and actually used is really important. And there's also one other that's kind of that I've been keeping my eye on, and that's the ML on board. So this is like processing onboard satellites. The implications of that are staggering. Like today, all the data has to come down to the ground before you do any, before you gain any insights. Imagine if you got the insights coming to the ground automatically, how much time you could save and what the implications are of that. So I think you're going to have a great, a couple hours of inspiration here, but those are my 3 that I'm super excited about.
Great. Thank you so much, Sashi. And Alex.
Yeah, those all sound super exciting. And I think it's important to also mention the work around climate science and earth science. It's interesting. Sometimes I'll hear from people outside of this group. I'm not too familiar with NASA and even AI and machine learning. They are surprised that we do a lot with climate science and earth science. And it is really important for us to kind of try to lead the way or contribute in the ways that we can with machine learning solutions. And the ways that we've been doing it, working very closely in tight feedback loops with stakeholders and domain experts and so on, I think is quite unique in the space. And this is clearly something that's on our minds, but it seems to be with each week, the public is more and more aware of how important kind of actionable insights are. And I feel like we have, again, unique opportunity to really lead the way here.
Absolutely.
That's a great point. Yeah, I'm excited that we've actually been growing our Earth science portfolio of challenges over the last few years. It's been growing, which is great. We've got 3 this year. So really important points.
Couldn't be more timely.
Yeah, that's definitely true. Great. Well, so we are at our time. I want to thank all of our FDL partners as well as Bill for joining me today. This was a really exciting conversation, and I'm very much looking forward to our showcase tomorrow, and I hope to see everyone there.
So one last comment about FDL and the showcase tomorrow. So one of the unique things about the FDL program is that this is a public-private partnership. So this is a partnership between NASA and the SETI Institute and academia and private industry and other government agencies. And that's what makes it so really exciting and powerful. And here with us today, we have our partners from the Luxembourg Space Agency and Intel. We also have partners like Google Cloud who bring massive compute resources to bear on the program. We have partners that include NVIDIA and IBM and US Geological Survey and the Lawrence Berkeley National Laboratories, the Mayo Clinic, MIT, and the list is quite extraordinary. And our partners bring funding, which allows the program to be truly international and global in scope and participation. They bring subject matter expertise, they bring technology. So we couldn't do this program without our partners. It's great to have a couple of our partners on board today, and also the mentors and faculty like Lauren and Alex who bring in their expertise and coaching and special knowledge to support the team. So it's really a team effort. It's really a global effort. It's a true partnership and collaboration. And we do hope you'll join us tomorrow. You'll be amazed, and it'll be lots of fun.
Great. And yeah, tune in tomorrow to see Bill and I and some of our FDL partners and researchers. So with that, thank you.
Thanks, everybody.